In this video, I'm going to show you the capabilities of the IntelliText OCR tool available in Microscan's AutoVISION machine vision software. I'm currently running AutoVISION in emulator mode with some preloaded images. These images contain dotted text with varying contrasts and noisy backgrounds. These are examples of direct part marks on metal surfaces. In order to read the text, first we need to insert the OCR tool and resize the region of interest to include all of the characters. By default, the tool will be applied as the standard AutoVISION OCR tool with basic capabilities. AutoVISION has the ability to apply image pre-processing. With image pre-processing, we can automatically improve images like these where some characters are not detected at all by the OCR tool and some characters are detected in the wrong size. Image pre-processing options are available by way of several filters. We have the ability to separate or connect objects, otherwise known as the open and close filters. We also have the ability to shrink or grow objects with the erode or dilate filters. There's a filter that enhances the gradient image or the edges of the characters, which is called the Sobel Filter. Lastly, there is a smooth noise filter that will do a low pass over the image to suppress some of the background noise, which is the mean low pass filter. To demonstrate what we can achieve with these filters, I'll select the closed filter and connect the light pixels in the image. And as you can see, the pixels or dots in the characters are now connected. And segmentation of the characters is slightly better. However, the tool still struggles with segmenting the character for N. A similar filter is the Dilate Filter. In this case, we will grow light objects again. As you can see, this makes the pixels grow together, so the white pixels move together and become fatter. This will make it a lot easier to segment discrete characters. But you can also see that some background noise and dust has become more visible with the Dilate filter. This can become a problem when reading text. The next filter that enhances the edges of the characters is the Sobel Filter. It doesn't help us on this particular sample, but what you can see is that the edges of the individual dots are enhanced, and we get a picture that shows the edges in the image. The last filter, and the one I'm going to use for this particular image sample, is the mean low pass filter. This filter helps to filter out the noise in the background, and also makes pixels grow somewhat together. As you can see, with this filter, we can see the individual characters are segmented properly. At the same time, it doesn't enhance much of the background noise, as was the problem with the Dilate filter. With the mean low pass filter, we can enable the standard OCR tool to read this text. But let's move on to a more difficult image to see how well it fares there. Here, you can see that the standard OCR tool struggles with this image containing a lot more background noise, some damage, and overall worse contrast. The IntelliText OCR tool has been developed to cope with these situations, and we can enable it by switching from standard OCR to IntelliText OCR. IntelliText OCR provides more control over the characters being read. As with the standard OCR tool, the IntelliText OCR tool has image pre-processing. So let's start by enabling the mean low pass filter again. Unlike the standard OCR tool, IntelliText OCR allows you to control the character polarity and the character width and height, both as a minimum value and a maximum value. It also allows you to control the binarization process. First, I'll select the proper polarity. Here we are trying to read light characters on a dark background. As you can see, the tool already picks up most of the characters, and it does a decent job of segmenting them. But the tool is depending too much on the ROI size. For example, if I decrease the ROI size slightly, we can see that the tool now has trouble segmenting the M and N characters properly. The next step will be to control the binarization process. This is the process by which we can turn a grayscale image into a black and white image. This can be used for character recognition by selecting the binary threshold mode and switching from auto to fixed template. We can see now that the image has changed. The yellow outlines show the binary image, and the yellow image is what is being used by the OCR algorithm for character detection. As we can see from this image, most characters will remain invisible to the OCR algorithm. In order to fix this, we can control two parameters, the binarization mean factor and the binarization dynamic range. The mean factor is the most important one, and you can adjust it to allow more or less tolerance with the characters in the binarization. As you can see, as we decrease the value, more characters become visible. However, if I go too far, a lot of background noise is also picked up by the algorithm. I'll raise the mean factor a bit, so most of the background noise is gone. Now we can adjust the binarization dynamic range to make the characters a bit fatter by lowering the value. If we go too far, the characters will start growing together, so I'll raise the value here as well to keep the characters nicely separated. If I resize the ROI slightly, we can see the effect on our segmentation. The N is now properly recognized, but the algorithm still struggles with the M. And you can also see that this G character is too high, which is due to the damage behind the characters. So let's adjust the minimum and maximum character size. First, I'll try to get the G to segment properly. What I'll do is change the maximum character height to something that is closer to the actual character height. When I do this, we can see now that the G is segmented properly. I'll use the minimum character width to solve the problem with the M. Right now the minimum character width is 1, so I'll change it to something like 20. And now the M is segmented properly and recognized as an M. These are the controls that are available with IntelliText OCR to improve the segmentation and binarization process, making reading tough OCR characters much easier. There are a few other parameters available in the advanced IntelliText OCR tool. For instance, I also have the ability to scale characters up or down. The ideal character size is roughly 30 pixels. So if the characters are too small or too large, I can scale them up or down with the scaling factor and make them easier to read. There's also minimum character pixels. Right now it's set to 20 pixels, and this basically describes the minimum area that a character needs to have in order to be a valid character. If the area is smaller, it will be ignored, which is an option that can be used to ignore noise in the background. So now let's look at how IntelliText OCR does on the previous image. We'll position the tool here, and as you can see, with IntelliText OCR, as with standard OCR, we are able to read the characters in this image. This demonstrates what can be done with the advanced capabilities of AutoVision's IntelliText OCR tool, and how you can adjust this tool for maximum performance.